Hey, welcome everyone. This is part 2 of Module 2, Task 7. And for this one, I'm looking at a scenario where both sides are reduced. They start out as x, so it starts out as x squared. But we're gonna make the reduction. So one, we're gonna reduce 2. Let's call that a minus 2. The other one, we're gonna reduce 3. Let's call that a minus 3. So we've reduced the 2, and then we come and we reduce the 3. So again, I've got minus 2x minus 3x, but then there's a problem here, right? Big problem. The problem is we actually reduced that last area twice. So reduced twice here. That is not good. We can't subtract something from nothing here. So we need to add it back. Otherwise, our model will be wrong. So I notice it is a 2 by 3. And so I notice it's going to be a 6. So I'm going to need to add back the 6 here. And so therefore my expression is going to be x squared minus 5x plus 6. Or alternatively, I could write it in base times height, and it's x minus 2 times x minus 3. So I know that this x squared minus 5x plus 6 is equivalent to the product of these two factors, base times height. All right, now from that, you notice it's a plus, and looking back, we've had a couple different scenarios. We've had one where we added a and added b to both sides. So what we're trying to figure out here is we're trying to figure out, well, what about the c term? Is it plus c or is it minus c? Okay, well, certainly if we're adding everything, then we're going to have to do a plus c. Okay, now if we're only reducing one side, we're going to need to subtract that third term, right? Because when we subtracted the x value, it was only part of it. And that's the same no matter which factor is positive and which factor is a reduction. But this was the strange thing over here. If we're subtracting on both sides, reducing both sides, we have to add it back. So in this case, it would be plus. And so that's the model standpoint. And sometimes it's hard for some folks to connect that to the models, and sometimes people prefer the algebra and the rules. And once you understand the model, it's good to go with these rules. So let's look at some possible rules here on how we can factor this. So keep in mind that all of these are expanded form or standard form. Ax squared plus bx plus c. And what we want to factor them is we want factored form. And factor is multiplication, right? And that's why one that we used was base times height, because you're multiplying the base times the height. Now, with a little bit of practice, you can often do these pretty quickly, but what I like to do is I like to look at the middle term. I notice this one is negative 3, and I like to look at the third term, and this one is negative 18. So this is kind of like the B and C. And what I do is I look at the possible products for the third term. Well, negative 6 times 3, 6 times negative 3, negative 2 times 9, 2 times negative 9, 1 and 18. What I'm looking for is I'm looking for a pair that adds up to my middle term. And I notice right here, negative 6 plus 3 equals negative 3. So when I add them together, these two factors, I get negative 3, that's my middle term. When I multiply the factors, I get a product that's equal to the C term. So therefore, the way that I would write this in factored form is going to be x minus 6 times x plus 3. And if you wanted to try that, you could use FOIL to test it. First, outer, inner, last. X squared minus 3x minus 18. So my explanation is find factors of the third term, okay, and which combination of factors adds to the middle term. And that's really the rule you can use. You actually don't need to do any modeling for this. You can just algebraically look at the third term. What do you multiply together to get it? And do any of those add up to